Welcome to the winter school. And today I want to share with you something that it will be useful since we will be using free open source software a lot these days. And since we are coming from abroad, from all the world, these tools will be very important to understand, let's say, how they work. So we will walk through all the definition of this free open source software in detail, so to understand what is the real meaning of these things. So let's start from the simple part. What is the software? A software is a set of instructions which is used to operate computers and execute specific tasks. So this is an example. We need a computer at this school to display maps. As we saw before with Riccardo, the computer program is something that is used to display a map. So, for example, here it is the map file displayed. The computer understands this kind of, let's say, order and displays a card. So if we go simple, the archetype of a program is the washing machine. So we have dirty clothes, we have a washing machine, and the program is the sequence of phases of washing that is necessary to get washed clothes or clean clothes. So this is the software, basically. We need the software to make machine working and to do task. Let's go with free software. With free software, we have to shift our, let's say, our focus on the language, because we are using English as the language of this school. And in the case of English, we have to discuss what does free means, because for a lot of languages, we speak about free software. For example, in Italian is software libero, where we have to translate as free software with free as freedom and not free as no cost. So in English, there is this kind of ambiguity that free software can mean free at no cost and at the same time free as in freedom. So the other languages do not require this discussion. So with free software, we are speaking about free as in freedom and not free at no cost, which is important to understand, and we will see after why it is important. Let's go. Open source. What is this open source for? Well, in this case, we have to understand what is the source code or how this software works. So to make a machine, in this case, a computer working, we need to program it. And so to program it, there are the so-called programming languages, which are like languages like we use to speak each other. In the case of the software and the computer, there are specific languages which are similar to the language we speak, but understandable by the computer somehow. So if we have to program something for our school, for example, to display a map, we have to write in a file some commands like open the map, read the data, put the colors on, display the map, and do it. And this can be written like in a programming language. Now, Python is very popular, for example, but there is also C, C++, C#. A lot of languages are around nowadays. But what's important to understand is that the machine or the computer understand just 1 and 0. So all these commands, or well, the instruction, have to be translated into machine code, executables. So when we install a software, we don't install the list of commands. We install a machine code, which is something that the computer understands and the human do not understand anymore. So open source means that the source code is open and editable. So now we are able to understand what is free open source software. So free open source software has a definition which is useful to understand when we use a program if it is free software, or FOSS for short. So every software that is free open source software has to, let's say, agree with these 4 points. One, the freedom to run this program, to run a program in all its functionalities for any purpose. So for example, if you run a program and this program doesn't work, let's say, in all its features, because, for example, you are a student and you don't have the license to do a full program, that is not free open source software. So you have to be free to run the program as it was programmed for in every functionalities. The second point is the freedom to study the program, how the program works. And this implies the access to the source code. So that is very important. We need to access the source code, even if you are not programmers, to have a free open source software. The third point is also important for our school, for example, the freedom to redistribute copies. Now, to make the exercise, we need, for example, QGIS, which is a free open source software for maps, for mapping. And in this case, we have to be free to copy or redistribute the copies of the software worldwide. This is necessary because otherwise the school will be very difficult without the software. The fourth point is also important, and we will see afterwards why, is the freedom to distribute changes, which also implies access to the source code. The freedom to distribute changes translates in the freedom to improve it. So if I have access to the source code, I can study it, and also I can find some problems or improvement, and I can do it and redistribute these improvements abroad. So how does this work, let's say, to describe that a software is free open source software? Basically, we need a license. Every software has a license. Every time we download a software, we have to accept the license. Every time we use a service, we check for the license, which is a document, which is a legal value, and is basically giving us the guidelines, or well, the legal statement of what can be done with the software. So a free open source software license will have all the 4 points we saw before in his legal document, which is basically a contract between the user and the developer of the software. So, for example, when you will be reviewing this material, you can check the license of QGIS, for example. You go in the Help menu, you check About License, and you see that there is this legal statement, very long because it is like in legalese language, which states all the 4 points we saw before. I will leave you the slides and also the link on a more in-depth description of what is free software and what is free open source software. You can really study also the historical point of view of it. So, but if we have the software for free for this school, for example, who pays or contributes to FOSS, or it is free because it's like low quality. So who pays and contributes to free open source software? Since the source code is available and the license allows to work on the source code and redistribute copies and improvement of the software itself, contribution, or well, the contribution can be divided in 2 groups. One is people's work. So for example, users. If you use software, you are automatically, if you use free open source software, you are automatically contributing to it, because the main thing of free open source software is to use it. You can also make feature requests. For example, if a free open source software lacks a functionality, you can ask for that. You can also submit issues. I found these issues with this software, it doesn't work in this case. You can discuss. with the developers or other users. Then there are contributors. Contributors are kind of users that are able to fix some glitches in the software, or they can produce documentation or can do translation. For example, you will see that QGIS is translated in your language, even if it is not English, Italian, or French, the most diffused, because some people in your country has contributed to it by doing the translation. And then there are the committers, so the developers. A lot of them are paid full-time to develop the software. But who pays them? There is the second group of contributors which are putting money, funding on that. So commercial companies are supporting free open source software. Governments are supporting, or research institutions, for example, INAF or agency like NASA or CNES, we will see, are supporting free open source software. Or universities, of course, that use the software, but also contributes to its development. So that is one kind of aspect which is important, that free open source software comes at no cost, but it has a cost. So how these mechanisms work. So this is interesting. Some of you will be, let's say, used to that, but some other will be amazed. So there is some software that is being developed to develop software. And this is super important. Nowadays, we have Git, which is this mechanism with some online platform like GitHub or GitLab that enables people to work on the same code remotely and without having to mess up, like writing on the same line two different things. So there are these mechanisms. I will not enter the details, but there are software platforms to develop software worldwide and in a collaborative way. Also, I want to mention, for example, Open Planetary, which is a group international initiative, and there is a forum where we can discuss about software at different level, like what is the software? I found the software, I found it useful, or can I develop this software? And the community it's answering to this. So the last point is geospatial. So what is geospatial? Well, simply enough, geospatial means that this software is relating to data that is linked to a geographical location. As we saw with Giacomo, we are dealing with geographics, with the spherical reference system, projected reference system. And nowadays, we are able to manage location across different bodies, starting from the Earth, the Moon, Mars, and all the bodies of the solar system. And that is geospatial, basically. And the more we are interoperable, the more we are having fun, basically, or the more we will be able to apply different studies to several bodies. Let's see some examples of FOSS for geospatial using planetary mapping, which is the main focus of our school. So maybe some of you will never use that because it's command line tools and libraries. So they are working behind the scene, but they are really important. So ProJ is a program, is a software or library that is used to do the projection. So Giacomo's talk before is all made. All the computation there are made with ProJ. And GDAL, which is the Geographic Data Abstraction Library, is a library which ensure that we can translate between formats and reproject data. So even if we don't see them working, those projects are the base of our work when we are doing FOSS4G for planetary. And then there are the desktop GIS. So QGIS, which is the one that we use for this school, but also there is GraphGIS, which is the historical desktop GIS that comes directly from the 80s and is really rich of algorithms, literature, and it's really a reference for GIS. And also Saga GIS, which is very used in applied science and hydrology a lot. Hopefully we have amazing software for planetary exploration. So Giacomo and Rick and Ricardo already mentioned the ISIS, which is the uh, integrated system for images and spectrometers developed by USGS Astrogeology Center in the US. And it is the reference for processing planetary data, images and spectrometers. And then if you want to produce DTM from stereo couples, the NASA Ames stereo pipeline ASP is the reference. It's all open source and they are available at the URL. Then there is this new program that came in this last decade, let's say, which is multi-mission GIS, which has been developed by JPL, by NASA JPL, and since it is open source, is being adopted also in working, for example, ExoMars mission Rosalind Franklin. So European Space Agency is taking advantage using a software that has been developed by NASA JPL by using MMGIS with ExoMars. And then there are other programs like CraterStat for doing crater counting, crater size frequency distribution, circle craters, open crater tools that we'll see at this school with Thomas, and MATPI that also we will see in this school and we will use in this school a lot, which has been developed by Luca Penaza, we will see later. So what are the organizations promoting and supporting free open source software? There are a lot now, hopefully. So GMAP since the beginning was the school that was promoting free open source software because the international aspect was very important, and this is the base why we are using free open source software in this school. Then there is the Open Planetary Initiative, which promotes not only free open source software, but also access to the data and to information abroad, to the information related to planetary data. OSGeo is the big organization, is a foundation that promotes geospatial for Earth, but also for planetary now at this point, because GDAL, ProJ, QGIS, GRASS are all part of OSGeo. USGS promotes ISIS, for example. ENAF starts to promote free open source software, and the license suggested is the same license of QGIS. The CNES, which is the space agency in France, supports free open source software as well. And NASA, we saw, is supporting open source a lot this last year. And this list is going to grow, and you can put your agency here for next edition of the Winter School, of course. So what are the good practice with free open source software? So as you start to understand, free open source software is not just a software you download, it's for free. Every software is a project that can be like a lot of people or just like a student that developed this software. So we have to be constructive when we submit a issue, or for example, we have to respect other people's work, because mostly it's sometimes is made by a voluntary will of people to share the software. In other case, we have to be like very professional to submit an issue, because otherwise submitting an issue like, QGIS doesn't work, is not useful to improve QGIS. So we have to be professional also on the user side if we want to see some improvements. But it is possible. And also another point, which is very important because most of you will work in research, is to cite the software as you do with the data and other people's work. Citing the software is crucial. So those are for some examples. So if you use QGIS and MAPI, for example, for your project, you should refer to QGIS and to, for example, MAPI, in this case, the work of Luca from 2021, because it's important to let's say, give back to the people that share with you the software, but also allow the readers to understand how to reproduce your work, because we are a researcher. So those are some examples, and you have it as a reference. So take-home messages from these FOSS for Geospatial in planetary. So free open source software deals with freedom of using, studying, and improve it, which is interesting because it comes for free, but it comes at a cost. And the cost is focused for its development and not its use. So basically, some organization pays for the development of the software, but they don't require you to pay for the ownership of that software. When speaking with about free open source software, we are not speaking about a software that is perfect or is bad, but everyone can improve it since we can study it. So the license is the power, let's say, the power of the free open source software, because even if a software is not perfect, if we use it and we support the development, it can be improved. And this is an example of QGIS. QGIS is supported, I think, by 400 institutions now, and it become better and better through the years. And the ones that followed the history of QGIS know very well that at the beginning it was like a pain in the neck. Now is kind of reference for that. So this is an example, but other softwares are like that. So another point is that in 2025, we have an awesome FOSS4G for planetary mapping. We can do our research completely end-to-end with free open source software for Geospatial, and that will be incredible for our research because we are really free to concentrate our, let's say, resources and efforts on scientific exploration and space exploration. And then good practice. When we speak about free open source software, we speak about project. We don't speak about ownership. So if we want to contribute, we have to be constructive, or well, it's better to be constructive than to be really like critical. It doesn't work like. So in this case, it would be important to think about what is really this free open source software. And also cite the software. Citing the software in your work, it's important. Even if you never support, you will never support the free open source software, just use it, and citing it will be a great, let's say, feedback for the developers and the future user, and it will enable reproducibility of your work because people know that you have used that software in that moment. So with this, I finished and I'm open to questions.